Alright, so number 35 on the homework is x to the 2/3 parentheses x plus 2. To start out, in our case, we distributed because the product rule gets very complicated. Trust us, we did it. It gets really ugly. So when you multiply x to the 2/3 and x, you have to remember the x in the parentheses has an exponent of 1. So when you multiply x's, you add the exponents together. So it'll be x to the 2/3 times x to the 3/3, which turns out to be x to the 5/3. Then the x to the 2/3 times 2 should be pretty easy, plus 2x to the 2/3. So that's just your normal equation. So now you got to take the derivative of that, and that'll turn out to be 5/3 x to the 2/3. Remember, you have to lower the exponent by 1, plus 4/3 x to the negative 1/3. And you get that by subtracting 1, so it would be minus 3/3, and that's how you get negative 1/3. So now you're going to simplify and try and get a standard form of the equation and just get the whole thing together. So when you simplify the 4/3 x to the negative 1/3, it turns out to be 4/3 cube root of x. So to get both parts having a common denominator, you got to add a cube root of x onto the 5/3 cube roots of x squared, because when you simplify the x to the 2/3, it simplifies to cube root of x squared. Okay, so now you gotta add a cube root of x to be able to get the same common denominator, so you can add both equations together. So now on the 5/3 part, you're gonna have 5/3 cube root of x, and you're gonna have an extra cube root of x squared on the top. So when you multiply the cube root of x squared and the cube root of x, you have to remember that the cube root of x turns into 1/3, and the cube root of x squared, that's 2/3. So again, when you multiply x's together, you have to add the exponents. So when you add 1/3 and 2/3, that makes 1. So you cancel out both of the square roots, and then thus you can make 5x. Thus you can make 5x plus 4 over the common denominator of 3 cube root of x. Okay, so now that we have these parts, now you got to find where the derivative is 0 and where the derivative does not exist. So yeah, to start off at the top, the numerator, you have to set it equal to 0, so you have 5x plus 4. Take the 4 onto the other side, so you have 5x equals negative 4. Divide by 5, and x will equal negative 4/5. So, and remember, we're trying to find the critical points and the local extreme values of this function, so you have to plug this part, the negative 4/5, back into the original equation. So you're going to have negative 4/5 to the 2/3 times negative 4/5 plus 2. And you can do this all by calculator, and what we got is 1.034, or which the book somehow simplified to 12/25 times 10 to the 1/3 power. Yeah. Mr. Shaplesky will accept the 1.034. It's just very complicated how they got the 12/25, so that's perfectly fine. So now we're trying to find where the derivative does not exist, so therefore you use the denominator, which is 3 cube root of x, and you set that equal to 0. you're going to cube root both sides, or you're going to raise it to the third power in order to cancel out the cube root. So this kind of looks ugly right now, so we're going to get rid of the square root, so we're going to raise it to the third power because it's a cube root. To get rid of it, then the cube roots will cancel. The cube root and the exponent will cancel, and you'll get 3x equals 0. Okay, so to start off, actually, you could just divide by 3 to get that away from the problem. 0 divided by 3 is 0. So you're left with the cube root of x equals 0. Now you would raise it to the third power to cancel the exponent out. So you would also have to do that to the other side of the equation. So 0 to the third power is 0, and you would have just x equals 0. And that is a critical point in the equation. Alright, so now that you have these 2 points, you now know your minimum and maximum, and you know what are the critical points. So you'll have 0, 0, and the other one will be negative 4/5 and 1.034 or 12/25 times 10 to the 1/3, but either way. And also you just know which one's your min and which one's your max due to the y value. So you know that the 1.034 is bigger than 0, so therefore it's your maximum. And that's all you do for this problem, and there you go.